So we have the example. So these are some examples. So you already saw some examples of the single displacement reaction, where you have a metal that would replace another metal from its compound in a chemical reaction, and then you would get a new compound plus the metal comes out of the solution. So you have a solid lithium, you have silver ions, then solid lithium is going to lose electron, and silver would accept those electrons that is coming from lithium. Silver would be reduced from silver ion to silver solid, the zero charge, because it's taking electrons now. But lithium, the charge of lithium on the reactant site in a solid format, in any like in elemental phase, it is or free state, the charge is zero, but after losing electron, it becomes lithium ion, so lithium plus, and then you would have lithium nitrate. If we do reverse reaction, so that means if we bring silver, try to react it with lithium nitrate, there is no reaction. Why there is no reaction? In this case, lithium is more reactive than silver. So the condition for this reaction is that the element that you are bringing must be more reactive than the replacing element from the compound. So because lithium is more reactive than silver, or silver is less reactive than lithium, this reaction will not take place. In other words, silver does not lose electron to lithium. Lithium is a better reducing, or is a stronger or more reactive metal than the silver, so there would be no reaction. If you mix two substances, you should not expect to have a reaction all the time. Sometimes you have reaction, other times there is no reaction. So that's why we know we have these like evidences for the reaction, and if you don't see any evidences, you don't find out any about any of the evidences by measurement, like change in pH or change in temperature. For change in pH, you have to use a pH meter, or litmus paper or pH paper, or change in temperature, use a thermometer, but change in color, you could see it. But if you can't measure or you cannot see a change, that means there is no reaction. So how do we know which element is more reactive? For that, you should always go back and check the activity series. We have the activity series on page 82 of the lab manual. Any element that is higher up is more reactive than the ones that are lower. What does it mean? It means that lithium can give electrons to potassium. Potassium can give electron to calcium. Calcium can give electron to any of these elements. But if you have mercury, mercury is not going to give electron to zinc. So the opposite is not going to work. If the element is higher up, that means it's more reactive, and that's why you know this as activity series, and it's going to lose electron or replace any of the elements, any of these metals in its compound or in the aqueous solution of those compounds. And hydrogen, or hydrogen chloride, or HCl, if you have, for example, copper here, copper is lower than hydrogen, so it cannot lose electron to hydrogen. But any element that is higher than hydrogen, it can lose electron to hydrogen. That means it's going to react with the acid. That means that it will, dissolve in the acid or have a single displacement reaction for the acid. But copper in this case, because it's lower level than hydrogen, there's no reaction. So based on the activity series, you can predict if there is a reaction or not. But even if you predict there is a reaction or not, you should still, in the lab, you should look for evidence if the reaction took place or not. When you are in the lecture, you just use the table and predict. But when you are in the lab, you predict first, and then you look for evidences. So you have to have some sort of a proof that yes, the reaction has taken place. When it comes to double displacement reaction, in double displacement reaction, in this case, you have two compounds in aqueous solution form, and the two compounds, if they can give more stable product, is going to form. More stable product, let's say if you have sodium chloride aqueous and then you have silver nitrate aqueous, and your product is silver chloride. Silver chloride is solid. So if combination of these two aqueous solution would yield to formation of a solid, the reaction will take place. If it yields to formation of a liquid, the reaction will take place. Or formation of a gas, the reaction is going to take place. In general, there must be more stable product forming, otherwise the reaction is not going to take place, and there would be no reaction. So in this case also, you are looking for evidence for reaction. And also the other technique that you learn here to predict which one is your, if the precipitate forms, for example, what is the precipitate? Is it sodium nitrate the precipitate, or the silver chloride is the precipitate? Because when you mix two clear solution, you have both of them in a bottle, or if you have both of them in test tube and they are both clear liquid, you mix it together, you will see a solid formed. You could say there is a reaction, but you cannot say, without knowing the solubility rules, you cannot say if that precipitate is a combination of which metal and which non-metal. But looking at the solubility table, you can predict or know which one is the precipitate that is forming. So how do we know silver chloride is solid? You have to look at the solubility table. We have it right here, solubility table. And you should be able to read what does it mean. You know, this is just a small table, but you can just use, and the actual table, I think for the unless there is no exception, the solubility rules will be provided for your exam, for the lab at least. But being able to use the table is your responsibility. So what it means, how do we know silver chloride is not soluble and that forms the precipitate? So if you look at this, this line here, it says most chlorides, bromides and iodides are soluble. So if most of them are soluble, why not silver chloride? So if you look at the exceptions, it says except silver chloride, mercury chloride, lead chloride, and the other examples that you have here. So if you look at the exceptions, and we know that silver chloride is in the exception part, and we know they are mostly soluble except these, then we know silver chloride is not soluble. Any compound that contains ammonium ion or metal from group 1A is going to be soluble in water. So it's going to be aqueous. Anything that contains nitrate ion is going to be soluble. So let's say if you go back to this reaction here, when you do double displacement, this is exchanging metathesis reaction, double displacement, or exchanging partner. So metal from the first compound goes with non-metal from second compound. So you're going to have sodium with nitrate, and metal from second compound goes with the non-metal from first compound. So you will have sodium nitrate and silver chloride. Another kind of short, cut here is like out, out, in, in. When you have two ionic solutions, out, out, that means that sodium from the, first compound, it goes with the nitrate from the second compound, and then silver would go with chloride. Is silver nitrate soluble or not soluble? If you didn't have this AQ here, can you tell me if sodium nitrate is soluble or not, and why it's soluble? If it is soluble, if it's not soluble, where do you see that in the table? All nitrates are soluble. Very good, very good. All nitrates are soluble, so sodium nitrate contains nitrate. So since there is no exception, then it is soluble. Is there another hint or another rule that would make sodium nitrate a soluble compound? What else? There's actually a double rule there for sodium nitrate. Okay, so if you have not memorized the table, I'm going to bring the table again. Now what? Which rule would tell us that sodium nitrate is soluble? Okay. The first one, it says all sodium compounds are soluble. Any compound that contains group 1A, and since sodium is coming from group 1A, if sodium is associated with any anion, so if you have a sodium carbonate, sodium sulfate, sodium nitrate, sodium nitrite, any of those is going to be soluble. So for those two reasons, we know that sodium nitrate is AQ. And then the other one, we still have to examine against the table to decide is it solid or not. And silver chloride. For silver chloride, we look at the table. There is no rule for silver, but there is a rule for chloride. And it says all chlorides are soluble with exceptions to mercury, lead, and silver. So if you have a silver chloride, that means silver chloride is not soluble. Yes, except for silver. Very good. So all chlorides are soluble with exceptions to silver chloride, lead chloride, or mercury chloride. So, and that is the mercury 1 chloride, actually, the one that we have on the table. So because of that exceptions, we know that silver chloride is not soluble, and the white precipitate that forms is actually silver chloride and not the sodium nitrate. So when you mix two compounds, two aqueous solution, if a double displacement reaction takes place, you must be able to see and catch evidence for the reaction, and then you write possible products, and you're following the in, out, out rule, or cation from the first compound with anion from second compound, and cation from second with anion from the first compound. You write it. Then you check it against the table. When you check against the table, then you are going to see which one. If there is any rule, you indicate that is soluble. And if there is a rule that is not soluble, then you would indicate as not soluble. If both products are AQ, what's the conclusion? If both products are AQ based on the table, let's say here instead of silver chloride, if you had like potassium chloride and both were AQ, then there is no reaction. Perfect. Then there would be no reaction because you started with mixture of 4 ions and you end up with mixture of 4 ions. So there is no reaction. Then the conclusion would be there is no reaction. If both of them are AQ, then you have no reaction. So When you are dealing with the double displacement reaction, you have few steps. First, you are going to write molecular equation. So molecular equation is the adding two reactants and predicting two products following in, out, or exchange cations. Then you are going to write the total ionic equation. When you write total ionic equation, so you break down anything that is AQ. You can, if you have any solid form, you leave it alone. You don't break it down because solids do not produce ions in the aqueous solution. If you have liquid like water or Br2, then you leave it alone. If there is a formation of gas, you leave it alone. You don't touch it. Okay. Solids, liquids, and gases would stay the way they are. Leave them alone. Do not touch them. You only break down the compounds that they are in aqueous solution or they are soluble. And it's a good practice going back like the charges, how to predict the charges and all that. So silver chloride, sodium chloride, you break it down to sodium plus chloride. Silver nitrate would be silver ion, and nitrate ion is a polyatomic ion. It helps you with the writing formula for ionic compounds as well. Sodium nitrate will break down to sodium ion and nitrate ion, but when it comes to silver chloride, you can't touch it. It has to stay the way it is. Solids, liquids, and gases. Then, after you have total ionic equation, you want to write the net ionic equation. With the net ionic equation, you are going to cancel spectator ions. What are spectator ions? Those are from the total ionic equation, you cancel anything that appears the same way, including the charges. So if you have a sodium ion would cancel. Nitrate ion would cancel with the nitrate ion. And what is left is the silver ion plus chloride ion that yields silver chloride. And that is known as net ionic equation. So these are the three steps that you are going to practice, just like the mole experiment that help you understanding and doing calculation with multiple methods of converting from mole to particle or particle to mole, mass to mole, and others from solution, all that. This experiment also is going to give you a lot of practices, and it's really nice that it helps you to understand the writing of the reaction, predicting of some of the reactions, and also breaking into the ions or dissociating the aqueous compounds into its ions, and being able to come up with the net ionic equation. The net ionic equation is actually responsible for evidence for reaction. When you mix these two compound precipitate forms, at the end, you see the net ionic equation showing formation of a precipitate. Like if you had an acid-base reaction, in acid-base reaction, formation of water is the evidence for reaction, and then your net ionic equation for acid-base reaction always is going to be like H plus, OH minus. It yields formation of H2O. And know how to use the solubility table. Remember, the first 5 rows, they are soluble, generally soluble with some exceptions. And then the last 5, they are generally insoluble with some exceptions. So all carbonates, they are insoluble, except if you have like sodium carbonate, potassium carbonate, or anything from group 1A carbonate, or if you have ammonium carbonate. And the same thing for sulfides. Sulfides are mostly insoluble with exceptions to these. So be able to read the table and use the table. Okay. When you perform the when you watch the video for performing the experiment, just pay attention so you can start you know, open it in two separate window probably, or share a window, or use different device. You watch the video and you record your observation, because from the video you basically can only record your observation. And after that, because if it says here that for the single displacement, your observation, what is the metal ion. Metal ion is the ion that is coming from the compound. So if you in test tube A, so for this you go back to the procedure from test tube A. In test tube A, you have PbNO3, so you have lead nitrate. Okay? So metal ion is going to be Pb2+. So that's your metal ion. So metal ion is the metal that is coming from aqueous solutions that you are placing in. And then the metal is what you are placing in the test tube. So if you're adding zinc is added to C, D, and E, but here you're adding copper. Copper, because you're adding copper to test tube A, copper is going to be, when it says a strip of copper, that is the metal. Metal ion is come from the solution that you have in the test tube. The metal is the solid piece. And then you look at you examine copper with lead against the activity series to see which one is higher up. If copper is higher than the lead, then there is a reaction. If lead is higher, then there would be no reaction. Or you look for evidence of the reaction to see if the new element or the new metal is going to form or not. So in the table for first part, for single displacement, you are going to look at the procedure and write your metal ions for the 7 test tubes. And then you follow the procedure to see which metal has been added to test tube A, B, and C, and then which ones are added to the rest of the test tubes. Then you look for observation. That observation is coming from the video. You record your observation. And then you could say if the reaction has formed or there was no reaction based on the evidence for each test tubes, for each mixture. For part 2, which is double displacement reaction, you have your two aqueous solutions, solution A plus solution B. So these are the two reactants. So when you are writing molecular equation, you are going to write the formula for barium chloride plus, and make sure you say AQ, and then plus sodium sulfate AQ, the formula for sodium sulfate AQ, and then you are going to draw the arrow sign and in, out, out. So it's going to be barium sulfate and sodium chloride. Barium sulfate, then you have to check the solubility table to see if barium sulfate is a precipitate or not. Then you write your observation when you are mixing. Your observation would be if there is a color change, if the precipitate formed, or it didn't form. Okay, so you write your observation here, and on the next step, when you're writing the molecular equation, you're going to add the two solutions from A and B and write the product. Make sure you write the formula. And one point of housekeeping, sorry. Do not print or write your answers on a piece of paper, take a picture, and upload. you're taking 1045 classes. Most of the students in science major, they are taking 1045 or going to like professional schools. So you have to type your answers. Please type your answers. Do not bring images. If you bring images for this experiment, you are going to lose some point. The reason I have them in a Word document, so it's editable, and you can use the editing functions from the Word. You can use equation editor. If I'm saying now, it doesn't mean that you have not followed these instructions. Maybe one or two of you are using like the pictures to insert a picture. Please don't do that. Type it. It might be hard the first two experiments, but since you're going to practice with the 12 different experiments, it's going to get easier. Editing, you know, it's just superscript, subscripts, it's like capital and lowercase. It's not that hard. So please type your answers. So for the molecular equation, you're just going to add the two reactant and predict the two product. At that point, you have to indicate which of the product is AQ and which one is solid. And then on the next step, you want to write the complete ionic equation. Just break down the anything that is AQ indicated into ions. And there might be some no reactions. So if there's no reaction, you don't have to bring it for answering questions 6 and 7. And for net ionic equation, you just cancel the spectator ions and you end up with net ionic equation. Questions for me? Okay, you actually have at least like 2 or 3 of this. Every semester I change the reaction, but the general question is there. So you will get like 2 or 3 of the same exact combination. And then the steps I give you, for example, reaction 5. And then for reaction 5, moving up, I would give you the sodium hydroxide and ammonium chloride. And I tell you, write the complete ionic equation, complete molecular equation, write molecular equation, ionic equation, and net ionic equation. So you have to do the same thing. So for sodium chloride, because it's soluble, you would put AQ. And then ammonium hydroxide, because ammonium is also soluble. So basically, this reaction 5, there would be no reaction. And if there is no reaction, then there is no, then you don't have to do the complete ionic or the net ionic. If you recognize right away that there is no reaction, or if you try to go with the ionic equation and the net ionic equation, everything would cancel. There would be nothing left for the net ionic equation. So for the exam, is going to be exact the same. If there is no exceptions. So for that reaction 5, for example, I was able to predict that both of them are soluble just based on general rules, because sodium, if it's in any compound, is soluble, and then ammonium, if it's in a compound, is going to be soluble. But if there is a, if I gave you, for example, reaction 8, copper hydroxide with sodium sulfate, then I would tell you the rule for solubility, or I would provide the solubility table. So I would include the solubility table and say, using the solubility table, predict if there is a reaction or no reaction. And then write molecular equation, complete ionic, net ionic from this experiment. It's a written exam, it's not a multiple choice. So you will get that, you could get that question. Okay, any other questions you might have for me? Oh, I forgot to turn on the camera, but it's all right. For part 2 observation, you would just say, yeah, just in the box, just say, what are the observations? Sure. Study guide for the exam, sure. I would. Is not going to be like a long review. I would tell you what type of questions to expect, and sure, there would be one, definitely. When we get close, like maybe a week before the exam. Sure. Any other questions? No questions? For part 2 table, no equation. You just write your observation, because if you write the equation, that would become the molecular equation, and molecular equation is in the next step. So you're writing it in the next step. So you don't have to write it 2 times. You could just say like a precipitate form, or if you want to even indicate which precipitate form, that's good. But if not, you will have to answer that question later anyway. Okay. Attendance? Hannah? Sahar? This is for attendance, so please use the chat or mic.
I'm here. Did you get me,
Sonia?
Professor?
Yes, I got you. Thank you.
Okay.
Sonia? Ashley? Leah? Caitlin? Jennifer? Greg? Carmen? Thank you. Carmen? Danielle? Davis? Caden? Saroti? Kate? I got it. Bianca? Manisha? Jada? Jose? Is Jada here? Jada? Yeah. Okay. Sierra? Javier? Lillian? Aisha? Matthew? And Ria. Well, okay. If you don't have any questions, thank you. Have a nice day. If you have questions, you may want to stay and ask your questions. You're welcome. Thank you. Thank you so much, Jim.